Howdy folks, we're going to run through solution methods for some what we call one-dimensional interaction questions. Here are a few steps, hints. We'll apply them to the following situations. Fred stands in a boat and tries to jump out onto the dock. There's his mass. It says he jumps out at that speed. What's the resulting velocity of the boat? So this is what we call a two-body interaction, right? And what we want to do is look at the system, the two-body system before the interaction. Well, there's the two masses. They're just sitting there. It does not say that before this interaction where Fred pushes off the boat. It doesn't say they're moving, so let's assume they're not moving. Afterwards, Fred jumps that way. The boat, therefore, must have an equal and opposite impulse and start moving the other way. Let's write down some things we know. Well, let's see. We know that M1 is Fred, 65 kilograms. M2 is the boat, 175 kilograms. V1 initial and V2 initial are 0. Over here, in the end, we know that V1 final is 6.5 meters per second. And I'm going to call it negative, because I'm going to use a sign convention where right is positive. Okay? Well, now, we're going to use conservation of momentum. M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. Now I should say that if you want, you are welcome to solve these things using that. You'll end up with the same answer because we got our statement of conservation of momentum from the fact that impulses are equal and opposite. That should be a delta. That's totally wrong. Delta P2. There you go. We got our statement of conservation of momentum from the fact that impulses are equal and opposite. Now, in lots of questions you see, some things will go away. In this one, those both go away because of that. We want V2 final. So, move the M1 stuff over, divide by M2. And we get negative, M1 65 times negative 6.5. All right, that's times negative, divided by 175.
I have Tinny.
Denny.
And you wanted me to pick up that banner.
Hi,
He's a
Lizzie.
friend too.
Hi, Lizzie. How are you?
I'm good. How are you?
Good.
Oh, this looks like fun.
Feces.
So that's whatever it is. Let's see, 65 times 6.5, 175, 2.4. Now notice we get a positive. V2 final is positive 2.41 meters per second. And since it's positive, I'll say right to the right. Okay? All right, let's try another one. Yeah, okay. Car, east, rear end of a truck, same direction, velocity 18 east, velocity of a truck. Okay, so here's the car, moving that way. Here's the truck, also moving that way. I made that vector for the truck longer because those vectors, don't worry about the length, but those vectors, if you're trying to make them represent momenta, then the truck's going to have more momentum in the beginning because it's so much more massive. In the end, the car slows down a little, which means that the truck must speed up a little if their impulses are going to be equal and opposite. But everything here is to the right. Whoops. Everything's to the right. So we can, let's see. We have M1, 1200. M2, 9000. We have V1 initial, 25 meters per second. And we'll say positive is east. V2 initial, 20 meters per second. We have a V1 final, 18 meters per second. And we're looking for velocity of the truck right after. So, if we stick with our standard method, M1 V1 initial plus M2 V2 initial, M1 V1 final, M2 V2 final. Nothing divides away here, or sorry, nothing is just equal to 0, so no terms go. And we're looking for V2 final. So that's just going to be, well, a lot of plugging in. M1 V1 initial plus, M2 V2 initial minus, M1 V1 final. That would be M2 V2 final. So we'll do this to solve for V2 final. I'll let you do that on your own, but you should see that the truck speeds up a little bit. Okay? Here's a case that you'll see a bunch of. You'll see this kind of what we call inelastic collision. Inelastic because we see that. And you'll see this a bunch. The wreck is motionless after the interaction. So you have two things moving at each other, and afterwards they're just sitting there. All right? So, oops. So, let's see. Let's call M1 the car. M2 the truck. V1 initial 20 meters per second, we'll call it positive for east. V2 initial, well, that's what we're looking for, right? Okay. Now, in the end, notice V1 final and V2 final are both 0. So if we want V2 final, whoops, we want V2 initial, don't we? Yep. So we get a V2 initial. So if we get a negative, what I would ask you to do here is say V2 initial is just 3.33 meters per second west. Right? We said positive is east. Okay? So those are the straightforward, as straightforward as we can get them almost, one-dimensional interactions. We'll get into two-dimensional interactions very soon. Okay, folks? Okay. I will see you tomorrow.